My name is Abhinav. I'm the team manager. I'm also the person responsible for the casing.
I'm Simel and Sean. We did engineering and the casing of the parachute, casing of the parachute.
I'm Alex. I'm responsible for the electrics and the programming.
Okay, so our primary and secondary mission, well, the primary mission was just the same as everyone, measuring temperature and pressure, but the difference was that we'd use the temperature and compare it with the previous 5 years and see the rate of global warming. And for the secondary mission, we decided to measure acceleration because recently 7 exoplanets were discovered, and we thought that maybe if a Cansat-sized satellite could go to one of those planets, could it actually descend? So the Cansat price, so most of the things we got were actually free, except for the batteries and the accelerometer. These added up to £10. But most of the materials were donated by our school, and we did raise a fund through a cake sale, which we will go into later. So the sustainability is the main part of our Cansat. So the materials we used were very eco-friendly. They were also recyclable, and also they didn't actually pollute the environment. We thought that this would be good because it would be going to another planet, and we don't want to destroy it like the way we destroyed ours. Software and electrical problems. So we did face many problems during the project, especially with the electrical problems. We did find that the Arduino board was releasing a lot of smoke because we did find that the battery was not placed properly. We also had difficulty learning the new language, C#, C++, and this was pretty hard for a programmer as he'd never actually done this before. And,
or any programming at all.
And the last problem, the biggest problem we actually faced, was finding the right library to put the accelerometer and gyrometer program into. This was hard because we couldn't actually translate the program to proper values.
Okay, so when considering the parachute, we sectioned it. We looked at two things. First of all, we needed to look at the mechanics of the parachute, and secondly, we needed to look at the materials. So with the guidelines and the help that we got from the STEM Centre, we saw that there were many formulas that they'd given us, and they seemed to overcomplicate the whole process. So we thought, scrap that. What do we have? We have a falling object on the planet Earth. That's all we needed. Well, that and descent rate calculator that we found online. And we used it to calculate the approximate acceleration, the time it would take, and the speed, and the average speed of the Cansat. In terms of materials, we researched a wide variety of materials, however we narrowed our options down to 4. So we had nylon, which is an abrasion-resistant material, and we thought that would be important because let's say we had high wind speeds, we don't want our material to, we don't want it to rip. We had silk, which is a strong, durable material, and it also has a bit of aesthetic appeal, We want it to look good when it goes down. And we had Dacron, which was very flexible. We thought maybe it could expand if there were high winds, then it wouldn't rip. And we also had Cansat, canvas, which was a strong and durable material, and it was easy to cut. We ended up choosing canvas because it was free supplied by the textiles department at our school. Easy to cut and shape, and they're very proficient in the stitching, sewing of canvas material. In terms of fundraising, we hosted a cake sale at our school where we sold cakes for 50p each and generated a total amount of £27. What was a really good motivator was that at the cake sale, some of the attendants, they didn't purchase cakes, but they gave us money anyway because they were confident in our abilities and they supported us and wanted us to succeed. In terms of outreach, we hosted assemblies throughout one school week where we talked to all the years and all the different houses in our school and explained to them what the Cansat project was about. Since 3 of us here are house captains, our connection with the students and our leadership really garnered support from them, and that was a real motivator. Lastly, in terms of outreach, we also use social media platforms such as Instagram, WordPress, which is a blog, and we had a Twitter account, which updated our followers and supporters with the events that were transpiring at the Cansat meetings in the months leading up to the competition.
So in In terms of the casing, we used 2 PVC bottles because one would not suffice to contain all the components. And we used PVC because it was very bouncy, so the energy was transferred to the surroundings rather than taking the damage itself. It was also very hard, strong, and meaning it would be less susceptible to damage. And it was recyclable, which supported our sustainability motto or theme. We used acrylic discs because they were very rigid, and we used a laser cutter to cut holes in them for the metal, the screws we used to hold the Cansat in place. And we used memory foam as a shock absorber. Because memory foam is very firm but it's protective, it could pop back into shape and make sure none of the wires were displaced, meaning no problems would occur, theoretically. So as you can see from the exploded drawing, the structure of the Cansat was modular, which meant that if any problems did occur, we could take the Cansat apart easily and detect the problem and reconstruct it within minutes. Yes, the battery was at the bottom compartment because it was stronger than the Arduino, and there were more shock absorbers at near the bottom. And the Arduino was at the top, so the antenna could emit data to the ground station.
So then, for our results, well, we had some problems broadcasting data which were due to wires touching and then signal cutting out, but the temperature, what we did discover is the temperature didn't change dramatically as we ascended. We lost data transmission while it was descending, so we only got data while it was going up. But the temperature, while it was going up, it didn't change that much. Nor did the acceleration. So the actual rate of rising was relatively, the acceleration of the rate of rising was relatively steady. Of course, the velocity was actually changing quite rapidly. The pressure, as it went up, and we expected it, did go down. And we can show that, obviously, as pressure goes down, the altitude also decreases. But no, unfortunately, we didn't manage to get anything while we were descending, and we weren't able to recover the Cansat, so we couldn't get any data off that. So if we were to do this again, we'd check the Arduino board wiring a little bit better, then that would stop us from losing data being broadcast from our transceiver to our receiver. We'd create an antenna so we could get a longer range. We'd create a smaller parachute so it was less likely to catch on things, and so it would descend faster. And we'd also convert the raw gyro and acceleration values into more recognisable forms such as Euler degrees and meters per second. The good thing though, it was eco-friendly, it was made from almost entirely eco-friendly materials, it was durable and it was very cheap to make, only costing £10, and the rest of the materials were free. And it was really great to try and team build that, to try and find all the materials, and it required a lot of different departments of the school to come together to help us and source the materials that we needed. Our Cansat 2016 to 2017. Yeah, it got stuck in a tree, like really, really stuck. It's not ever coming down, ever. No. So we do think on one hand that's going to be up there for noise. It's in memoriam of you know, Cansat for all of us and everyone, and it's been really accomplished something there because that's never coming down. No, that's never coming down. But no, stuck in the branches. So unfortunately we weren't able to recover any data off the thing because, well, we can't recover any data off it.
But we did see that the Cansat was not actually broken and the parachute didn't actually
The parachute didn't rip, no, nothing ripped. We would probably want to make the parachute slightly less durable because that meant it would have ripped and it wouldn't have got stuck up a tree.
So for the credits, we were sponsored by various organisations such as the Jack Petty Foundation. They paid for our transport, thanks to them, we're here. And Uxbridge High School, the students and the teachers, they donated a relatively large sum of money for us during the cake sale, and their support obviously helped us through our journey. And the people who could not attend were Kavlash and Kavnash Jayaraja. They were a vital part of the team, and without them couldn't be here. They managed the social outreach and the design of the Cansat. And our special thanks go to the DT, Science and Computer Science Department because they helped us during non-school hours and put a lot of effort in the Cansat, and our mentor, Mr. Rubio. Thank you very much.
Well, hopefully you can get the data next year, maybe. Did you have any recording on the Cansat itself?
So
So we had some data which was sent while we were ascending, but about halfway up during the ascent, data cut off, and it was a known bug, and it was a possibility it could happen, and we were just hoping it didn't, but it did occur when it was about halfway up, and then so we didn't actually get any data during the descent.
Did you save any data in the Cansat?
So we didn't know there wasn't an SD card or anything on there which could have saved data, so no, we've lost the all data's been lost because we lost connection.
You can leave it there in the tree.
Yes.
Did you have any problems with the recycled materials that you wouldn't have if you used new materials?
Certainly, things like the parachute and the canvas, there were different materials more modern materials we could have used, which would have been better suited. Certainly for the casing as well, there were different materials we could have used, and so yeah, all that sort of stuff would have been better if we'd used more modern materials. But at the same time, I don't think it stopped us from achieving our goals. You know, we had a couple of things that banned up. I don't think that was due to our materials. So no, I think the use of recycled materials worked just as fine as anything else did.
You want it to be ecological, right?
It's a shame it's not biodegradable.
Yeah.
No, thank you very much. Thank you.